All right, in our last section of Chapter 3, we're going to look at geometric distributions. All right, a geometric setting arises when we perform independent trials of the same chance process and record the number of trials it takes to get one success. On each trial, the probability of a success has to be the same. So what's the difference between binomial and geometric? The biggest difference is that there's no set number of trials here. The number of trials y it takes to get a success is the variable. It's the geometric random variable. So that's the big difference here, is we don't know the number of trials. That's what we're trying to find. That's the variable. So the probability of y is called a geometric distribution with these parameters. The probability of a success, that has to be the same for every trial, and the y values, that it could be the answer, could be 0, 1, 2, 3, all the way up to however many trials it takes to get the success. So there's really no ending value. It could take 20 trials before you get a success, right? All right, in the board game of Monopoly, one way to get out of jail is to roll doubles. So suppose that a player has to stay in jail until he or she rolls doubles. Probability of rolling doubles is 1 out of 6. So A says, explain why this is a geometric setting. Well, y is the number of attempts it takes for the player to roll doubles. Okay, we don't know how many times they're going to have to roll. That's the variable in this case. And then I check the other conditions of bins, except for the n. So B, is there a clear success? Well, the clear success is a double. The fail is not getting doubles. I, is one roll independent of each other? Yes. And the probability of success is 1 out of 6 every time you roll. So the BIS all work, okay? And the n, how many attempts it takes, that's my variable. So B says, define the geometric random variable and state its distribution. So I would say, y is the geometric random variable with a probability of success of 1 out of 6. So notice I define it and state the probability of a success in this question. Okay, part C of the Monopoly question. Find the probability that it takes exactly 3 rolls to get out of jail. Okay, so remember, y is the number of attempts until the player rolls doubles. Well, they're asking us, what's the probability that y is 3? So let's think through this. That means I had 2 fails and then a success. So the probability of a failure is 5 out of 6, times 5 out of 6, and then a success, 1 out of 6. So I could rewrite this as 5 out of 6 squared times 1 out of 6, and that gives me this probability. Well, then let's think, what's probability of exactly 4 rolls? That means I have 3 failures and 1 success. So I do my probability of a fail 3 times, and then 1 success. 5 out of 6 add up to the 3rd power, and then my 1 success. So hopefully you're beginning to see a pattern here, because let's look at 100 rolls. If y is 100, that means I had 99 failures until I got my 1 success, which gives me this in the calculator, but I would never write this as my answer. That's not okay. This means there's really 8 zeros in front of that too, which makes the probability virtually 0. So I would write approximately 0. So you need to be able to see this pattern resulting, okay? P minus 1, the probability of a failure, is going to be your number of trials that they're asking you, the probability of minus 1, times the probability of your 1 success. So that's what we did here. Our failure probability was 5 out of 6, and trials minus 1, so 100 minus 1 gave us 99. Here's our 1 success. So if you need to think of this p to the 1st power, that's great. Do it. But this is the equation for a geometric distribution. So hopefully you've seen the pattern, and so now looking at the formula for a geometric probability, it should make a little sense. If k is the probability of, getting your first success on the 5th trial, then you had 4 failures right here. It's 1 minus this value, and then you had your 1 success. That's what we just saw on that last example with Monopoly. Okay, so in your calculator, in that distribution menu, you have 2 options. You have Geometric Pdf and Geometric Cdf. These work the same as the binomial. Pdf is when it's perfectly equal to exactly what they want, and it'll ask you, have you 2 parameters, probability of success and then probability of a success on the 5th time or 10th time. It'll tell you what K is. The CDF version of the geometric distribution is like the other one. It's a less than or equal to, and you have the same two parameters. But remember, it's adding up all the probabilities up and equal to this parameter right here. So be careful to use this one only when needed. So in general, how do you calculate the mean of a geometric distribution? That equation looks like this. The expected number of trials required to get the first success on average is 1 over your probability of a success, right? So you really have to read carefully and identify that this is geometric to know which equation to use for mean. All right, so on average, how many rolls should it take to escape jail in Monopoly? Remember, the probability of rolling doubles is 1 out of 6. So on average, I'm looking for the expected mean. I'm going to use my formula. 1 over 1 over 6 gives me 6 rolls. On average, it should take you 6 rolls. So interpreting it, on average, it will take approximately 6 rolls to get out of jail in Monopoly. All right. So what's the probability it takes longer than average to escape jail? Well, longer than average means greater than 6, right? That means 7 or higher. So in order to find this probability, I can't use, there's no greater than in my calculator, there's only less than or equal to. So I need to find the complement then, 1 minus the probability that I get 6 or below. This probability, remember it's cumulative, I can find with my calculator. If I find this probability right here and subtract from 1, that's going to give me the probability that's greater than 6. Now, this is an or equals to, so this includes 6. I don't want to include 6 here, but I do want to include it here. So pay attention and think through it slowly if you need to. So I'm going to use my geometric CDF function with the probability of 1 out of 6 and x being 6. I'm going to find that value, subtract it from 1, and I get this answer. All right? So you have to be crafty on how you use your geometric CDF function given the question at hand. Now, what does this probability tell us about the shape of the distribution, right? Well, since only about 33% of the data is above the mean, this is the mean, right? In a symmetric distribution, it should be 50% above, 50% below. But if only 33% is above the mean, that can tell us that it's going to be right skewed, okay? Again, and that's because symmetric distributions, the means would have 50-50. But if it's less than 50 over here, that means it's getting pulled this way and there's more data on the left side of our graph. All right? So we'll try some of these on your practice questions. It's important that you get used to reading these and deciphering binomial versus geometric and using the appropriate equations.